For the next 3 sections, we're going to be talking about what are called counting rules. And here's the basic idea. So when we first started talking about probability and we're looking at sample spaces and events, writing out the sample space can be nice and short, or it can be incredibly tedious, right? So let's think about if I just roll 2 dice, right? And the sample space would be writing out every possibility for those 2 dice. So on the first one, I could get a 1, and then I could get 1, 2, 3, 4, 5, or 6 on the next one. So that would be for the sample space 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, so that takes care of all the, if I got a 1 for the first die. Now, what if I got 2? Okay, well then it would be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. That would be, I'd have to write out 36 different things, and that's just rolling 2 die. What if it were 3? Or like, what happens when I flip a coin 10 times or something, right? These get like explosively huge in terms of how many things I have to write out in these sample spaces. And in the end, all I really cared about was the bottom of my fraction when we're doing these probabilities is how many things were in the sample space. So for that, I didn't necessarily care what the things were. I just needed to know how many things were there, right? So if I just have a count, that would be fine. And for the top of the fraction, I needed to know how many things, right, were like that event in the sample space. Well, sometimes I may want that written out carefully in a sample space. Sometimes I don't really care about that either. I just want to know how many things are there. And so these sections on counting rules are essentially getting us out of having to write out all that stuff so carefully and just get us directly to the counts. So that is really the main idea. And we're going to start with the kind of basic idea of how I can actually write out these counts for our sample spaces in our events without actually having to do that. So we're going to think of things as a number of steps, okay? That's really the key to understanding how this stuff works. So to explain what I'm talking about there, if I'm rolling 2 dice, I don't think of it that way at all, because there is no difference between rolling 2 dice and then rolling, and like that's one thing, versus rolling 1 die twice. And the advantage to thinking of it as rolling 1 die twice instead of 2 at the same time is that I can think about one thing happening at a time. And it is so much easier to work with things like that instead of multiple things happening at once. So we're going to think of things as a series of steps, right? So, right, if I'm flipping a coin 3 times, right, I don't want to think of it as I flipped 3 coins at once and like all the different things that could happen there. I'm going to think about it as flipping 1 coin 3 separate times, right, as 3 steps, right? I'm going to flip it once, see what happens then, flip it a second time, what happens then, flip it a third time. So that's the main idea. Okay, so let's think about the number of outcomes in these sample spaces, okay? Recording the genders of 3 children. All right, we didn't do a ton with tree diagrams in this course, but here's how you would start something like that if you haven't seen these much. Right, so the first child, right, so I'm going to think about this. I don't want to think about having 3 children like all together. I'm thinking about 1 child at a time, right? So here's the first child, and then let's think of the second. So if the first one was a boy, the second one could also be a boy or a girl. And if the first one was a girl, the second one could also be a boy or a girl. See how these kind of just branch out, and that's why they're called tree diagrams, right? And then we'll think of the third child. So if the first 2 were a boy and then a boy, that last one could also be a boy or a girl. This last one could be a boy or a girl if it was a boy and then a girl, right? And so as I do this, and I kind of make a branch for each one of these possibilities off the previous branches, I get all of this, right? And if I needed to write out that sample space, right, I just go down each branch, right? So this would be, to get here from the base of my diagram, it'd be a boy, and then a boy, and then a boy, right? So B, B, B. And then this one would be a boy, and then a boy, and then a girl. And then this would be a boy, and then a girl, and then a boy. right? And so on. Which would have mattered if we were still in that section where we were writing out sample spaces. For right now, I just want to know how many things there are. Right, so that would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so how did I get to that 8? There were 2 possibilities here. There were, right, so a boy or a girl. And then in this second scenario, there were also 2 possibilities for, biological sex of the baby, boy or girl. And then I've got 2 here also. What happens if I just multiply those? 2 times 2 times 2 gets me that 8. Okay, so 8 is the answer to that. And I kind of gave you a hint there of how we would be doing these calculations to figure that out. Rolling a die and then flipping a coin. Okay, I'm going to do the same idea with this tree diagram just because I think it explains this multiplication a little bit better. Right, so I'm going to roll a die. Well, there are 6 possibilities there, right? 1, 2, 3, 4, 5, 6. These, I could get 1, 2, 3, 4, 5, or 6 when I roll a die. And then, for the second thing that I do, so this is my first step and my second step. That's what I'm doing here is thinking of these as individual steps. I'm not rolling a die and flipping a coin and like, how is all that working together? I'm thinking of them individually. So if I rolled a die and got a 1, I could get heads or tails after that. Got a 2, I could get heads or tails after that. Heads or tails. Heads or tails for 4, heads or tails for 5. And then heads or tails for if I rolled a 6. Well, if we count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes, and we could write them out, right? It would be 1 in heads, 1 in tails, 2 in heads, 2 in tails, 3 in heads, 3 in tails. That's not super important, as I talked about. Most of the time, we're really just interested in figuring out how many things are in that sample space. Well, how did I get to that 12? Well, when I roll a die, there are 6 possibilities of what could happen, and when I flip a coin, there are 2 possibilities. What would happen if I just multiply those? I get 12. Okay, so I think you're already kind of getting the idea here, but let's just do one more. All right, so I'm going to choose a cheeseburger or a hot dog to eat, and then I'm going to choose soda, milk, or water. All right, cheeseburger or hot dog. Okay. So that's a cheeseburger or a hot dog. And then I had 3 choices of what to drink, which were soda, milk, or water. So, soda, milk, water. Soda, milk, water. And again, I'm not thinking about this as a meal. I'm thinking of it as step 1, pick my food. Step 2, pick my drink. I'm thinking about it as 2 separate steps. And how many total things do I have here? 1, 2, 3, 4, 5, 6. I could certainly write out the sample space here, but I kind of don't care. Right? I just need to know that there are 6 possibilities. And how do I get to that 6? Well, there were 2 choices of food, and there are 3 choices of drinks, and I get 6, right? So this whole thing of making tree diagrams, writing out sample spaces carefully, will become less and less important for certain things where we can use these counting rules to make sense of our probabilities without, again, having to resort to that very theoretical definition using sample spaces and events.